Welcome to another interesting mathematics class. My name is Manola Ndiomu, and today I'll be taking you on probability part 2 under the theme everyday statistics. Now, before we go into this lesson, let's take a look at the objectives for this class. By the end of this lesson, you should be able to calculate the probability of the resulting experiments, and you should be able to apply the occurrence of chance events or probabilities in everyday life. In the previous part of this lesson, we learned that probability is a branch of mathematics that deals with how random events occur. We also said that probability is a mathematical way of describing how likely an event will occur. And going on, we learned that it is expressed as a fraction, decimal, or percentage. In today's lesson, we will learn how to find the probability of resulting experiments, and we'll also learn how to analyze statistical data using probability. Now, going on, it is important to note that probability of an event based on experiments is known as experimental probability. To carry out experimental probability, we perform an experiment and the results are written down. Now, from these results, we can now calculate the probability of the events. For example, we have a coin and we toss it 10 times. Now, every time the coin is tossed, we record the outcome of the coin toss. Now, from the experiment, we can now use the record to calculate the probability of the next outcomes of the coin toss. Let's look at some examples. Example 1. Doye writes down the number of male and female children of her mother and father. She also writes down the number of male and female children of her parents' brothers and sisters. The result is shown below. Now, with the table given, find the experimental probability that when Doye has children of her own, her firstborn will be a girl. B. If Doye eventually has 8 children, how many are likely to be male? Now, from the table, we can see that in Doye's family, there is a total of 8 male children and 24 female children. So that gives us a total of 32 children. So solving for A, if Doye's own children follow the pattern of her family, then the experimental probability that her firstborn will be female will be number of favorable outcomes over number of possible outcomes. The number of favorable outcomes will be number of female children in her family, which is 24, and the number of possible outcomes will be the total number of children in her family, which is 32. Simplifying 24 over 32 will give us 3 over 4. So the experimental probability that her firstborn will be female is 3 over 4. B. Following the pattern of her family, the probability of getting a male child will be number of favorable outcomes over number of possible outcomes. The total number of male children is 8. So the number of favorable outcomes, which is number of male children, is 8. And the number of possible outcomes, which is the total number of children, is 32. So the probability is 8 over 32, which simplified will give us 1 over 4. Note that we use 4 to simplify our fraction. Now, we are not done because they asked us for the number of male children Doye will likely have. So the number of male children Doye is likely to have will be 1 over 4 of 8, where 1 over 4 is the probability of getting a male child, and 8 is the number of children she may have. 1 over 4 of 8 will be 1 over 4 multiplied by 8, where 4 will cancel out 8 to give us 2. So if Doye eventually has 8 children, she will have 2 male children. Example 2. 2 dice are thrown at the same time. A. What is the probability that the sum of the 2 dice is an even number? B. What is the probability that the sum of the 2 dice is greater than 9? C. What is the probability that the sum of the 2 dice is a multiple of 3? D. What is the probability that the product of the 2 dice is less than 12? And E. What is the probability that the product of the 2 dice is 24? So from this question, it is said that 2 dice are thrown. Now A to C is talking about the sum of the 2 dice, while D and E is talking about the product of the 2 dice. So starting with A to C, we create what we call a sum table. Now on this sum table, the first row contains the content of the first die. And remember, a die has 6 sides. So we name it from 1 to 6. The first column has the content of the second die, which is from 1 to 6. Now, we fill the table using our first row and our first column by adding. Now, for example, if we get 1 in the first die and 1 in the second die, our sum is 2. Or if we get 2 in the first die and 3 in the second die, our sum is 5. Now, if we get 6 from our first die and 4 from our second die, our sum is 10. And that's how we populate our sum table. Now, from this table, we can calculate the number of possible outcomes that we have. Counting from our first solution to our last solution, we will see that the number of possible outcomes that we have is equal to 36. So now that we have the total number of our possible outcomes, we can go on to solve our questions. Now, question A. What is the probability that the sum of the two dice is an even number? Probability of an event is number of favorable outcomes over number of possible outcomes. We have the number of possible outcomes, and from the table we can also find out the number of favorable outcomes. Now we have to find the probability that the sum of the two dice is an even number. Now from the cells, we count how many even numbers occupy the table. Now let's count how many even numbers occupy the table, excluding the first row and the first column. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So this means the number of favorable outcomes is 18, all over the number of possible outcomes, which is 36. Now, simplifying this using 9, 9 will go into 18 to give us 2, and 9 will go into 36 to give us 4. Simplifying this some more using 2, 2 will go into 2 to give us 1, and 2 will go into 4 to give us 2. So the probability that the sum of the two dice is an even number is 1 over 2. B. What is the probability that the sum of the two dice is greater than 9? Now we go to our table and we count how many numbers are greater than 9. So we have 1, 2, 3, 4, 5, and 6. So the number of favorable outcomes will be 6, all over the number of possible outcomes, which is 36. Using 6 to simplify, 6 will go into 6 to give us 1, and 6 will go into 36 to give us 6. So the probability that the sum of the two dice is greater than 9 is 1 over 6. C. What is the probability that the sum of the two dice is a multiple of 3? Going back to our table, we count how many numbers are a multiple of 3, excluding the first row and the first column. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of favorable outcomes is 12, all over the number of possible outcomes, which is 36. Now 6 will go into 12 to give us 2, and 6 will go into 36 to give us 6. Simplifying this some more, 2 will go into 2 to give us 1, and 2 will go into 6 to give us 3. So the probability that the sum of the dice is a multiple of 3 is 1 over 3. Now, for question D and E, we are focusing on the product of the two dice. So we create a product table. Now, just like the sum table, the first row contains the faces of the first die from 1 to 6. And the first column contains the faces of the second die from 1 to 6. Now, in the sum table, we populated the table with the sum of our two dice. But in the product table, we will populate the table with the product of our two dice. For example, if we have 1 on the first die and 1 on the second die, our product is 1. Or if we have 3 on the first die and 4 on the second die, our product is 12. Or if we have 6 on the first die and 5 on the second die, our product is 30. Now let's use this table to solve questions D and E. Now, just like our sum table, the total number of possible outcomes on our product table is also 36. Now let's go on to solve our questions. Question D. What is the probability that the product of the two dice is less than 12? Now going to our table, we count the products that are less than 12. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the number of favorable outcomes is 19, all over the number of possible outcomes, which is 36. We can simplify this further, so the probability is 19 over 36. Question E. What is the probability that the product of the two dice is 24? Now we go to our table and we count how many products are 24. We have 1 and we have 2. So the number of favorable outcomes is 2, all over the number of possible outcomes, which is 36. Using 2 to simplify this, 2 will go into 2 to give us 1, and 2 will go into 36 to give us 18. So our probability is 1 over 18. Now, it is possible to find the probability of events occurring in everyday life. Let's take a look at some examples. Example 3. A survey was done to find out how every student in JSS at a school were usually transported to school each day. The information was written down in the table below. What is the probability that a student chosen at random rides a bicycle to school every day? Give your answer as a fraction in its simplified form. Now, step 1. We determine the number of possible outcomes. Now, the number of possible outcomes here will be the total number of JSS students. So we calculate the total number of JSS students from the table. That is 10 plus 20 plus 10 plus 15, which will give us 55. Step 2. We determine the number of favorable outcomes. Now, the number of favorable outcomes is the number of students that ride their bicycles. From the table, we can see that the number of students that ride their bicycles to school is 20. Now, step 3, we determine the probability that a student chosen at random rides their bicycle to school. Probability is equal to number of favorable outcomes all over number of possible outcomes. We got our number of favorable outcomes to be 20 and our number of possible outcomes to be 55. So our probability is equal to 20 over 55. Using 5 to simplify, 5 will go into 20 to give us 4, and 5 will go into 55 to give us 11. So our probability is 4 over 11. So the probability of a student chosen at random riding a bicycle to school is 4 over 11. Having solved all those examples, we have come to the end of this class. But before we go, let's take a look at a quick summary of all that we have learned so far. First, we learned that probability is a branch of mathematics that deals with the occurrence of a random event. We also learned that probability is a mathematical way of describing how likely an event is to occur. Next, we learned that probability of an event based on experiments is known as experimental probability. And finally, we learned that it is possible to find the probability of events occurring in everyday life. It's test time. Question 1. The midday temperatures in Lagos for a week in February were as follows. What is the probability that the midday temperature on the next day will be 27 degrees Celsius? Option A, 3 over 7. Option B, 1. Option C, 4 over 7. Or option D, 0. The correct answer is option A, 3 over 7. Now, how did we get that? We were given 7 temperatures, so the number of possible outcomes is 7. Now, if we count how many were 27 degrees Celsius, we will find out that there were 3. 1, 2, and 3. So the number of favorable outcomes is 3. So the probability will be equal to the number of favorable outcomes all over the number of possible outcomes, which is 3 over 7, which is how we got our answer. Question 2. 2 dice are thrown at the same time. What is the probability that the product of the 2 dice is greater than 20? Option A, 5 over 6. Option B, 2 over 9. Option C, 1 over 12. Or option D, 1 over 6. The correct answer is 1 over 6, which is option D. Now, how did we get that? From our product table, we will count how many of the products are greater than 20. We have 1, 2, 3, 4, 5, 6. So the number of favorable outcomes is 6. And if we count the number of possible outcomes, you'll see that we have 36. So the number of possible outcomes is 36. Using 6 to go through, 6 will go into 6 to give us 1, and 6 will go into 36 to give us 6. So our probability is 1 over 6. Thank you for your time. I'm sure you can now solve probabilities that occur in everyday life. Till we meet again, bye-bye.